In this video, we take a look at random number generation. So there are many examples in computer science of where you may need to create a program that is required to generate a random number. And we've just put a few examples on the screen. Maybe a program that simulates the roll of a dice or generates a random set of coordinates. Any sort of gamelin simulation or a national lottery program. Possibly a quiz program which selects a random question from a set of questions. And often in cryptography, we need to create random numbers. Here, we've got some example code written in Python that shows how we might generate and use random numbers. So in Python, we start by importing a random library of functions called random. Here we have 3 lines of code, and each line is generating its own random number. We supply the random function in Python with 2 parameters. The first number is the lowest value that could be generated, and the second number is the highest value that could be generated. So we generate 3 random numbers from 1 to 6 inclusive and store the results in dice 1, dice 2 and dice 3. You're now free to use these stored random numbers as you see fit in the rest of your program. So let's just recap. There are many situations when you might want to generate a random number in a computer program, and a few examples are just shown here on the screen. At the bottom of the screen, we've shown you how random number generation will be presented to you in the exam when they use the OCR exam reference language. They simply use the function random followed by brackets and 2 parameters, where you supply the lowest number that should be generated and the highest number that should be generated. So my variable equals random brackets 1, 6 brackets generates a single random number between 1 and 6 inclusive and returns the result to be stored in the my variable. So that's really all you need to know about random numbers for the specification. If you're interested, however, about how computers truly generate random numbers, then the rest of this video might be quite interesting to you, because it's a little bit more complex than possibly you've thought. So you may be wondering how a computer can actually generate a truly random number. So where does this randomness factor come from? Computers, by their very nature, are deterministic, and by this we mean that computers work off algorithms. And as you know, algorithms are simply lines of computer code. So how random can numbers generated by a fixed algorithm truly be? Is it possible to predict a sequence of so-called random numbers generated by a computer algorithm? Well, to answer this question, we need to look at the difference between pseudo-random numbers and true random numbers. Now, for most situations, generating pseudo-random numbers is enough. If we run this example code below, it might appear that it generates a random list of 10 numbers from 1 to 100. So I've got for I equals 0 to 9, so I've got a for loop running 10 times, print a random number between 1 and 100. Every time that random function is called, the random number generator kicks in, and indeed it does appear that we've got a list of 10 random numbers from 1 to 100. You'll actually find if we ran that code multiple times, it would generate exactly the same sequence of seemingly random numbers every time. So not so random now then. Pseudo-random number generators need to be supplied with what we call a seed value. This is a value which changes every time the algorithm is run. This value is then passed in or taken in by the algorithm and is used in the calculation to alter the output list of random numbers that are generated. Now, seed values is really another whole video all on its own, but you need to generate some random value each time. And one example which can be used is what's known as the Unix epoch time. The Unix epoch is the number of seconds that have elapsed since January the 1st, 1970 at midnight. At the precise moment of writing this sentence to this video, the Unix epoch time was 15761574585, and there are websites you can go to find out the exact epoch time at any single moment. So now imagine we call the code below again. At the precise moment that random is called, the seed value for the Unix epoch time is passed into the random number generator. It's used in the calculation and the random numbers are output. We then run the program again, and of course a different seed value is used. So now the program outputs a different set of 10 random numbers. Now, generating pseudo-random numbers is fine in most cases, but for much more secure situations, for example cryptography or generating encryption keys, we need to generate what are known as true random numbers. Now, to generate a true random number, the random number generator needs to gather entropy. And what we mean by that is we need to gather data from the physical world around us, random data from the real world. There is no way of generating true random numbers by using purely deterministic methods in a computer. Computers are predictable, whereas the natural world around us is truly random. Now, we really are going beyond the spec here, but it's quite fascinating. Some examples is a computer could measure the radioactive decay of an atom. Quantum mechanics tells us that this will never decay at exactly the same pace. Measurements can be taken, and this data is truly random. On Linux systems, there's the ability to run a function called devrandom, and it generates truly random numbers. It does this by blocking the random number generator until a certain amount of entropy is gathered from the real world. We see in the second screenshot, it says, when creating a key, we need to generate a lot of random data, and you can help with this. By performing some random actions, like typing at the keyboard, moving the mouse and using application, this gives the system the random data that it needs. So the system is monitoring you typing the keyboard, and there is no precise logic or determination as to when you press one key and when you'll press the next. Your actions are not predictable, they are truly random. So as you can see from this little exploration, the whole field of generating random numbers is actually quite a fascinating one for computer scientists. Trying to get a very logical device such as a computer to generate a truly random number has never been something which is easy.